Here's an example where I'm going to simplify some rational expressions where you've got a polynomial on top of a polynomial. So with this first example, let me say with both examples, your first step is to pull out any common factors in the numerator and denominator. So for example, if I look at this numerator for example A, I notice that there's a common factor of 25 here and here. So one thing I could do to start out part A is to factor out 25 in the numerator. Also looking at the denominator, there's a common factor here of 5. Now when you're figuring out what's left after you pull out a common factor, what you should do is divide by whatever you've factored out. So for example, in the numerator here, I factored out 25. Let me see if I can change colors. For some reason, it's always a little hard when I'm recording. And this is going to look a little messy, but if I divide both terms in the numerator by 25, that gives me the remaining expression here when 25 is factored out. So 25t squared divided by 25, the 25s would cancel there and I'd have just t squared, minus 100 divided by 25, well, that's 4. Similar thing in the denominator, if I factor out 5, then to figure out what's remaining after the 5 is factored out, I can divide both pieces by 5. So here the 5's cancel, so I'll have just t plus 10 divided by 5, that's 2. Now at this point, what you should notice is that numerator is what we call a difference of squares, a perfect square minus another perfect square. And if you have anything of this form, perfect square minus another perfect square, I'm going to write it as a squared minus b squared, that will factor as a minus b times a plus b. This is what's referred to as a difference of squares and the way that that factors. So t squared minus 25, that's t squared minus 2 squared, so that factors as t minus 2 times t plus 2. And let me color code this a bit. I know I'm writing all over the place, but so this expression here, which is equal to this, factors as t minus 2 t plus 2. So in the numerator, I'm going to replace that t squared minus 4 with t minus 2 t plus 2. And then I've still got 25 out here, 5 in the denominator, t plus 2 in the denominator. So now this common factor appears, t plus 2. And I can only cancel these t plus 2's when this is written as a product. So since I have 25 times t minus 2 times t plus 2, and then the denominator 5 times t plus 2, I can cancel the t plus 2's. If this were 5 plus t plus 2 in the denominator, and then let's say I had a t plus 2 on top, it would be incorrect to cancel the t plus 2's in that case. Okay, but let me get rid of that. Okay. Sorry. A little overexcited. So the final answer to part A here is 25 times t minus 2. Whoa, divided by 5. Yep. See, I am a bit goofy here. So 25 divided by 5, we should go ahead and divide that since it divides cleanly. Or if you think of it as canceling a common factor of 5. So our final answer here is 5 times t minus 2. And doesn't that look so much more, nice and clean compared to what we started with in that example A? All right, so I'm going to do the same thing with example B. Example B gets a little bit trickier because we have two variables, x and y, to deal with. But we should start with the same idea. Let's look for common factors here. So in the denominator, across this denominator, I'm scanning for common factors. I see that 2 is a factor of the first part of this subtraction and the second part. So in that denominator, I'm going to leave the numerator alone for now. Looks like we can factor out 2. We should also check the variables. So I've got y cubed here and I've got y squared here. So when you're identifying common factors, you always factor out the lower exponent. So if I'm saying, okay, I've got powers of y in the first part and the second part of the subtraction, which power do I factor out? It's always the lower one, so it's going to be y squared. Now to figure out what's left here, again, we divide. So I'm going to erase some of this. So if I'm going to factor out 2y squared, then to figure out what's left, let me divide both parts by 2y squared. So here, the y squareds will cancel, because I have that on the top and bottom. And then 4 divided by 2, that's 2. So I'll have 2x cubed from the first part of that difference in the denominator. And then in the second part here, the 2's cancel. I have y cubed divided by y squared. The lower power cancels, and then what's left is the difference. It's 3 minus 2, so y to the first. So this is just, the 2 cancel, this is just minus y. Now, I would notice that, well, I've got 8 divided by 2, so 8 divided by 2, that's 4. Also, get another color, we've got y to the first in the numerator, y squared in the denominator. So, and let me kind of copy down the rest of this real quick. I'm going to try that again. Y to the first in the numerator, y squared in the denominator. The y is going to survive wherever the higher power is. So we're still going to have a power of y on the bottom. And the power that's left, if we cancel y to the first, then we should subtract 1 from this exponent. So now it's y to the first in the denominator. And then what else is left? So we did the 8 divided by 2. That's the 4 right here. Still have this x here. We didn't do anything with that. This y to the first canceled. In the denominator, the 2, we already accounted for that with the 4 here. That's 8 over 2. Y to the first, so I wrote that already. And then we've got this 2x cubed minus y expression. And so this right here, I know it's written a little messy, but this will be our final answer. That's as simplified as we can get. There's no factor of the denominator that's also a factor of the numerator at this point.